Hello, and welcome to Using SQL in R by me, Dr. Adam Brain. For those who know SQL already, then all you need to know is the next slide. For those that are new to SQL, then we will work through plenty of examples. This course has little on theory, just application, covering important data, the select statement, the where clause, joining data frames together, creating new columns, and so. And this is your basic SQL code setup. First of all, you need to set up your libraries. Main one here is SQL DF. And you notice in the second half of the slide is how you write your SQL code. Example 1 would be your data frame, SQL DF, open bracket, double inverted quotes, is your SQL code, to be completed by the double inverted quotes and a closing bracket. The course setup is as follows. There are 4 different sections to this course. Number 1, the basics. 2, joining data frames. 3, creating new columns within a data frame. And 4, the analysis. Each section follows the same setup. Activate the libraries so that we can use the SQL code. Import our CSV file to create our data frame. Then we write our code to create our solutions. Data and code for this presentation is available on drbrainstats.com under Learning SQL in Python R. Before we start our first session, we must first activate our libraries, especially the SQL DF. Our second part is to import our CSV file to create our data frame. In this case, tablex. You can either use a code as shown or just use the import function within R. And as we can see, we have now created a data frame called tablex based on the data within tablex CSV, which has been stored in our SQL folder. This course was created using RStudio, only because of the ease of viewing the data frames. As you can see in this example, by just clicking on a tablex, you can see your data frame. So first session, the basics. And so we start our first SQL code. We're going to create a new data frame called example 1. We're going to select the columns ID, col 1, col 2 and col 3 from the data frame tablex. And this is our solution. Example 1, that's our new data frame. SQL DF, open bracket, double inverted commas. That's our command where we must write our SQL code within it. And we can see we've written select ID, col 1, col 2, col 3, because these are the columns we want. And we want these from the data frame tablex, as shown in the code. Our second SQL code involves creating a new data frame called example 2. We're going to select the columns ID, col 8, col 7, col 3 and col 5 from a data frame tablex. As you can see, this code is very similar to the previous one, apart from we have now changed the order of the columns. This is to show that the order of the columns you write in the select statement is the order they appear in your new data frame. In our next example, we want to select all of the columns from a data frame tablex. In this scenario, you're going to see that we don't need to write down every single column individually. We can use select star. This is a shortcut in all SQL code, which means all columns. So if you click on data frame exam 3, it will show you exactly the same table as tablex. With the basics done, we will now progress to the next stage, the where statement. Where statements are used when we want to choose specific data based on a certain criteria. For example, we want to create a data frame called example 4 that contains all of the columns from data frame tablex where ID equals 10. Now we are familiar with select star and the from statement. The only additional text from previously is the where command. And you can see we've got where ID equals 10. That's it. If you clicked on our data frame example, you will see the result of just one. Now we can proceed to the next stage of a where statement. We want to create a data frame called exam5 that contains all of the columns where the ID is less than 10. Again, this code should be very similar as the previous one, but we just got the less than sign instead of the equal sign. Exam6, we want to contain all of the columns where the ID is greater than or equal to than 10. As you notice, the code is very similar again. It's just we got the greater than or equal to sign in a where statement. Sometimes within a where statement, we will need multiple conditions. This slide introduces and, or, and in. For the and example, we're going to select columns ID and col5 from a data frame tab X, where ID is greater than 5 but less than 12. As we can see from results, just look at the where statement. See where ID is greater than 5 and ID less than 12. It's that simple, that's straightforward. Next, the or statement. We're going to create a data frame called examp8. We're going to select the columns ID and col3 and col8 from a data frame tab X, where ID is either 9, 20 or 27. Now we can see in the where statement we've had to use the word or in between for different criteria. If you wrote down where ID equals 9 or 20 or 27, this would not work. You would need to write down the actual column name, in this case ID. This brings us on to the in statement. We're going to select columns ID and col3 and col8 from a table tab X, where ID is either 9, 20 or 27. This is the same as our previous example, but instead of writing down ID equals 9 or ID equals 20 or ID equals 20. And so we proceed to character-based variables. In our first example, we're going to create a data frame called examp10. We're going to select all of the columns from the data frame tab X, where col1 equals A. Please just note the where statement, where the letter A is in inverted commas. In our next example, we're going to create a data frame called examp11. We're going to select all of the columns of the data frame tab X, where col6 equals A. You see, in the first time this was done, this would actually produce an error, because the character-based variable within the where statement is case sensitive. So to make this correctly, we need to use the capital A. So when using character-based variables, you must remember to use inverted commas, and the text is case sensitive. Our final slide, covering the basics, shows multiple conditions within a where statement using character-based variables. For the and statement, we just want to show where col1 equals lowercase a and col6 equals uppercase a, and we can see in a where statement. And finally, we can use the and statement and the in statement together, as shown in example 14. You just must place characters in brackets separated by commas. Our second session involves joining data frames together. It is a rare occurrence when all of your data requirements are available in one data frame. SQL is capable of many types of join, but this course covers the left join and inner join, as over 99% of your work can be completed with. So first, we're going to activate our libraries and import the data. In this course, we're going to use Table 1, Table 2, and Table 3. So first, left join. Left join allows us to select data that's only relevant in one of the data frames and when it matches in the other data frame based on a certain column. So in our first example, we're going to create a data frame called left1. We're going to select all of the columns and rows from a data frame table 1, and where the ID is the same on table 2, we're going to use a column animal. So we can look at the script. Now, we have given our data frames aliases. Table 1 has been given the alias A. Table 2 has been given alias B. These aliases have been applied in the select statement. This tells SQL where the column should come from. Left join tells Python that we want all of the data from table 1. And the on statement tells Python the column from each table that the table is to be joined on. And this is our solution to the left join. As we can see, where animal is not matched by ID, R has given this a value of NA. Our next example of a left join involves creating a data frame called left2. We're going to select all of the columns from the data frame left1, which has just been created, and the num column from table 3. We're going to give data frame left1 an alias of A, and data frame table 3 an alias of B. And we're going to left join table 3 onto left1 using the column ID. Now we can see where table 3 has joined into left1 and there are no values. This has been given a figure of NA. And as before, we have shown that we can use select star, and you can use a select star statement within the joins. Our next join is called the inner join. We're going to create a data frame called inner1. We're going to select the columns ID and letter from data frame table 1 and animal from table 2, but we're only going to bring back data where the IDs are the same in both data frames. So as before, we have given our data frames aliases. Table 1 has been given the alias A, and table 2 has been given the alias B. These aliases have been applied in the select statement. Inner join tells us we want data where it is the same from table 1 and table 2 based on their joining column. And the on statement tells Python the column from each data frame that a table is to be joined on. And this is our solution to the inner join. And as you can see, it will only bring back 11 rows, because this is when the ID in table 1 and ID in table 2 are the same. Our next example of the inner join involves creating a data frame called inner2. We're going to select all of the columns from data frame inner1, which was just created, and the num column from table 3. We're going to give data frame inner1 an alias of A, and data frame table 3 an alias of B. Use the inner join on table 3 onto inner1 on the column ID. And as you can see, this only brings back 3 rows. This brings us to our third session, creating new columns. It is very rare when a data stored has everything you need. It is very common to create new columns based on other columns within the data frame. This next stage involves creating new columns. So as before, we're going to activate the libraries, and we're going to import the CSV file tablex to create. In our first example, we're going to create a column called count that has the value of 1. And this is the SQL code as shown on the slide. To break this code down even further, you can see that new col1 is our new data frame. 1 as count means that we are creating a column called count that contains the value 1, as shown on the slide. In our second example, we're going to create a new column called char, which has a value ABC. To break down the code even further, new col2 is our new data frame. ABC as char means that we are creating a column called char that contains the value ABC, as shown on the slide. In our next example, we're going to use values from another column to create our new column In this case, we're going to create a new data frame called new call3, and we're going to multiply id by 10 and give it the name num. As you can see from the code, this means we'll be creating a column called num, which is based on the column ID that's multiplied by 10. It's that straightforward, and results are shown in the table. Our next stage involves creating new columns using the case when statement. The case when statement is very powerful within SQL. It allows you to use multiple conditions to create a new column. Our first example will translate the following into SQL. We're going to create a new column called new call with the following values. When call C equals C, make the value equals 10, else make it 20. So we're going to create a new data frame called new call4, and we're going to break down this case when statement even further. Case when. This is our command to tell it we want to create a new column based on certain criteria. Call3 equals C then 10. This is our statement to populate the value 10 whenever call3 equals C. Else 20. For any other value where call3 does not equal C, give it a column a value of 20. And the end statement. This is a very important command. That means that the case when command has finished. As new call. And this gives the column its name. We can see the results on the slide as well. And now we can proceed to a more advanced example of using the case when statement. We can create a new column called new char with the following values. When call 9 equals W, make the value equals wish. When call 9 equals X, then make the value equals X-ray. When call 9 equals Y, make the value equal yes. Else give it the value So again, case when. This is our command to tell it we want to create a new column based on certain criteria. Call 9 equals W then wish. This is our statement to populate the character wish whenever call 9 equals W. Call X then X-ray. Our statement to populate the character X-ray whenever call 9 equals X. Call 9 equals Y then yes. Our statement to populate the character yes whenever call 9 equals Y. Else For any other figure, give it an end. A very important command that means that the case when command has finished. As new char, this is our new column name. And this is the result again shown on the slide. We have nearly finished creating our new columns session. This slide will demonstrate using examples of using the in and the and commands. Rather than just read out the code, please just view it. Press pause. This may be there to demonstrate that you can create more than one column in each SQL command. Fourth session, analysis. Basic analysis is a very important tool. Analysis can help us check if our data is correct. As before, we want to activate the libraries and import the CSV or tablex to create our data frame, tablex. Before we can proceed with the analysis session, we need to create a new data frame called data1 using the data frame tablex and create 3 new columns. We're going to create a column called count, which has a value of 1, a column called new num, so when call 8 equals Q, give it a value of 10. When call 8 equals R, then give it a value of 20. When call 8 equals S, then give it a value of 30, else give it a value of 0. And finally, a column called new num1. So when call 4 equals J or K, then give it a value of 40, else 50. The code is shown. Our first example entails summing up all of the values in our column count. So our SQL code here is select sum open bracket count close bracket as total. This is the SQL command to sum up all of the values within a column count. And as there are 30 rows, we expect the total to be 30 as shown here. So now this leads us to the group by statement. So in this example, we want to know the total number of different categories in column 9. So we need to look at the code in a group by statement. Select column 9. We must include a column we want to group everything by. Sum count. This is a SQL command to sum up all the values within a column count. And we also got now group by column 9. This is the SQL command that tells it to group the statistics by the different values in the column. As there are 30 rows and the different categories contain 10 observations each, as shown. Our next example of group by. Sometimes we may want to group more than one variable. In our example, we want to summarize the number of observations with col3 and col5. So before we got our select statement, which includes col3, col5, and our sum open bracket, count close bracket. But in our group by as well, we've now got col3, comma, col5. And this is our results. You can see in our final example of analysis, we're going to show that you can summarize more than one variable and calculate the average. We can use col4 as our group by. You can see we've got our sum count, which you'd be familiar with. Sum new num, very familiar again. Our new command here is avg, open bracket, close bracket, and this tells it to calculate the average, and results are shown here. And that's it. Thank you for listening to a quick introduction course using SQL within R. If you thought this course was interesting, please view my other training videos. You may be also aware that I currently have books available on Amazon that are all very reasonable priced, which will go along with the videos. Thank you.